Hello, day 19 is over and it's time to make a video report about what did I learn today. As you can see, my eyes are red. That means what? That means I did great today. And it also means that exams are coming since it is the last week, and after 1 week I'm going to finish my studies. After that I'm planning to do an internship, and yeah, I'm kind of excited. I will finally be able to see what the job is all about, right? So before that, I want to tell what did I learn today. And today I decided to dive deeper into the chemistry, and finally, and I stumbled upon probably one of the coolest teachers on YouTube, Professor Dave's videos, and how he explains chemistry. Yeah, it's pretty cool. I mean, he could explain the chemistry better than like during on his 5-minute video he could explain the basics of chemistry like much better than my teacher, my professors all combined. Anyway, so today I learned some fundamentals about elements, about matter, about the word matter, what does it mean, like what does it represent, and all that stuff. I also learned something about atomic numbers, some extra information about atomic numbers, and mass numbers, and how to define those numbers. Yeah, it turns out you can do some pretty cool things knowing this information on chemistry. What else? I also learned something about I finally understood why do we use all those 10 with a power of 9, with a power of 10, with a power of 8, like all those numbers on the equations all of the time. That was so confusing, but thanks to Professor Dave, I finally understood it. And some Chinese. Yeah, I did some Chinese as well. So I would love to start with matter. What's the matter? What matter really is? And it turns out matter is anything, like anything that has shape, that has a form, or that has a mass, or anything that occupies the space. So that's the matter. The thing, something that exists. Yeah, I think that's the simplest way of explaining it. So there are basically 3 phases of the matter. The first one is solid. The solid is where it has a fixed shape, and all the particles are stretched together, so they're touching and they do not move. So that's what we call a solid. So for example, hey, my sticker, right? Or basically everything. Cup, it's a solid. Or I don't know, like everything that is solid. The second phase is liquid. Liquid, that's water, obviously, or anything that anything that has a fixed volume but does not have fixed shape. So water is probably the best example of liquid phase. And the third phase is gas. The gas phase. All about gases, and it doesn't have fixed shape, it doesn't have fixed volume, and it always just moves around filling the space, the whole space. So that's what that. These are the three phases of the matter. So it turns out matter can change its form, whether by physical or chemical changes. So, for example, the physical change, perhaps the simplest example is when ice melts, right? When ice melts, molecules inside are basically the same molecules, but the way they are arranged are changed. So that's why we call it a physical change, because the molecules, the chemical aspects of the substance are the same, but its form has changed, or the way it reacts, or the way it acts changes. And there's also a chemical change. Chemical change is all about the change, like when the substance just changes its molecules. It's all of the molecules inside of the substance just change from one type of a molecule to another. So that's a chemical change. So and what else? Oh, here's a fun thing. It turns out water is not an element, as I used to think before. It turns out it's a compound or molecule. Water. Yeah, that's right. H2O. And mixtures. Mixture is made of two or more substances, and these can be separated by physical processes. So, and there is a thing. There are two types of mixture. The first one is homogeneous mixture, where all of the substances are located evenly. So it means they just mix with each other, and you cannot see you cannot tell exactly how, where is what. Like, you cannot say exactly which substance is where. Like, where is it? Where is the substance, or where is the first substance and where is the second substance? Because they're mixed, right? For example, the sugar, when we mix sugar with water, you just, after you mix them, you cannot see the particles of the sugar, right? You just see the water. And yeah, that's a homogeneous mixture. And the second type of a mixture is heterogeneous mixture. That is vice versa. You can exactly see the substances, the types of the substances on the mixture. So, for example, when you mix oil with the water, the oil is gonna just lift up, creating that layer, and you can see the exact line between oil and water, and they do not mix with each other. So that's a heterogeneous mixture. That means substances are not located evenly, right? And there is this thing called pure substance. Pure substance is one that can't be separated into other materials by any physical processes. Water, for example, water is still water whether you freeze it or boil it, right? So yeah, that's why it's a pure substance. Yeah, enough about the matter. It doesn't matter anymore, huh? And the atomic properties. So I had a problem with charges. I didn't actually understand how those charges are defined, and it turns out when the amount of electrons are less than are less than the amount of protons which are responsible for the positive charge, that means it's positively charged. But when the amount of electrons are bigger than the amount of protons, that means it's negatively charged. The atom itself is negatively charged. So why is it negatively charged? Because electrons are responsible for negative charge. So if there are more electrons, that means there are more, the whole atom is negatively charged. So for example, if there is let's say one extra atom, or there is one atom more than a proton, that's gonna be -1, and it should be written in the molecule or in the atom property. Yeah, I got it. Oh, and the difference, if there is a difference between numbers of protons and electrons, that's isotopes. Yeah. What else? Oh, no. Not isotopes, ions. So if there is a difference between numbers of electrons, that's going to be ions. And if there is a difference between if there is a different number of neutrons, that's gonna be an isotopes. So what else? Oh, mass number. Well, mass number is basically the number of protons plus number of neutrons. That's gonna be a mass of an element. Easy. So what else? Yeah, that's basically it. Atomic number, mass number, charge, number of protons, number of neutrons, and number of electrons, and of course nuclide symbol. Those are the main properties of element that needs to be written when we're doing equations, for example, or just trying to define or just trying to work with chemicals. I think that's enough for the chemistry, but actually I have some extra information about numbers. So it turns out in chemistry or in physics or anywhere else, we work with large numbers. So in order to not waste too much space on our paper, we use scientific notation. That means scientific notations includes 1 digit and decimal point after that, and the amount of numbers after the decimal point is defined by the sigfig, the significant figures, and we multiply that number by 10 with the power of, it depends. For example, there are kilos, there are kilos, there are gigas, there are hectos, there are decas, there are centis, there are millis, right? Millimeter or millisecond, and etc. So for example, for kilo, that kilo represents 10 with the power of 3. That's going to be 1,000, right? So instead of writing down the number 1,000, we instead write 10 with the power of 3. That's much easier, actually, and that helps us to work with a large amount of numbers, or vice versa, like a little amount of numbers. So Yeah, kilos. As I mentioned before, kilo represents 10 with the power of 3. That means kilogram is going to be 1,000 grams, right? And there is a word milli, which represents vice versa, 10 with the power of minus 3. So 10 with the power of minus 3, it means that's gonna be like very small numbers, and yeah, for example, millisecond, that means we need to multiply 1 divided by 1 over 1,000 multiplied by 1. So that's gonna be, so it means 1 millisecond equals to 0.001 seconds. Oh, by the way, when we work with numbers, when we work with measurement, we always use seconds for time. We always use, oh, not seconds, or yeah, seconds for time. We use seconds. For lengths, we use meters, and for the weight, we use grams. So milligrams, millisecond, millimeter, or let's say centimeter, right? What else? So what else can we do with scientific notation? There's a question. So it turns out a lot of things. For example, we can convert units from one to another. For example, we can convert minutes into seconds, or years into seconds, or megabytes into terabytes, or vice versa, terabytes into megabytes, and etc. Yeah, we can do some cool stuff with it. For example, we can answer the question, how many seconds do we have in a year? So using the scientific notation, we can answer that question, and after the simple equation, simple calculations, we define that in 1 year there are 3.15 multiplied by 10 with the power of 7 seconds. That's gonna be 1, 2, 3, 4, 5. Yeah, a lot of seconds. That's it for the chemistry. That's it for physics, I guess. I think that was the beginning of physics, all these scientific notations, but I don't know, it just helps me out, because every time I sit in those classes, there are those equations on the desk, and they usually write it that way, like 10 blah 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 multiplied by 10 with the power of like 7, 6, 5, and etc. So it always confused me, but now I know why is it for, and yeah, it's pretty cool. I like it. So now it's time for Chinese language. 你好吗？今天 What did I learn today? I've learned some new words and some cool grammar. For example, the first word for today is going to be 爱好你的爱好是什么 or 你的最大的爱好是什么 it means hobby, like 爱好 your hobby 你的爱好 your hobby. And there's a cool grammar that says, for example, 他的爱好跟我 不一样，不一样，一样 means like 跟 plus 一样 means same, or 不一样 means not the same. So just as I said, 他的爱好跟我不一样. So it means his hobbies are not the same with my hobbies. And you can also add something like 他不喜欢打篮球，他不喜欢打篮球，我喜欢打篮球, right? Yeah, it's pretty cool. It's pretty cool grammar, and I'm pretty sure I'm gonna use it a lot. And there is a word 记得 Yo, Kim, how to pronounce the word 记得 like remember 记得 记得 means remember. 我记得你的名字，我记得你的名字。I remember your name. Yeah. What else? 你的最大的爱好是什么？听音乐。听音乐 means listen to music. 听音乐。So what else? Oh, 以前 like it means in the past or before something. 以前他喜欢打游戏。It means before he used to like playing games, like 打游戏 playing computer games. 以前他喜欢打游戏，现在他喜欢学习。It means now he likes to study. Before he used to like playing games, but now he likes to study. 以前 pretty helpful. And 明天下午3点以前 or 今天5点以前你有时间吗？ It's like do you have time today before 5 p.m. 下午今天下午5点你有时间吗？ Yeah, something like that, I believe. And the last example for 跟 and 一样 like the same, not the same. 我的爱好跟你一样，我也喜欢打游戏。你的爱好跟我一样，我也喜欢打游戏 or 打篮球 or anything else which is related to your hobby. So that means my hobby is the same with yours. I like to play basketball as well, or I like to play computer games as well. Blah blah blah. And that's it for Chinese for today. Yeah, it was a good day. I enjoyed a lot of new knowledge, a lot of good materials, and now I guess I'll spend most of my time preparing for my upcoming exams. Good luck to me, and I'll see myself tomorrow.